Hello. Does that mean I'm live? Hello and welcome. We're having just some tiny bit of technical difficulties, it looks like. But I'm here and welcome. Thank you. I'm here from the Discovery Theater. Click, maybe try, there's a button on the bottom and it will like reset it usually. Yeah, there we go. We're here. Welcome to the Discovery Theater. My name is Melissa. I am lucky enough to be your blue coat today, where I have prepared some experiments for our sort of virtual PA day. We know you're off school today, and we thought it might be fun to kind of hang out. So with me, I have Megan. She is going to be my camera person. She's going to help me to answer some questions. If you have any questions throughout our presentation, you can put them in the chat box, either from whatever platform that you're watching this video from, and we'll hopefully be able to answer your questions. So I wanted to talk a little bit about physical and chemical reactions. So I did a live demonstration a few months ago about Coke and Mentos. And I had a lot of cool questions and things that I didn't get a chance to try in that live session that I wanted to try out today. So I want to do a few things together first before we get to our like Coke and Mentos rockets. So I said we're going to look at physical and chemical reactions. So what do I even mean when I say that? So when we have a chemical reaction, we mix some things together and we make something new. When we have a physical reaction, we can mix things together, something happens, something changes, but there's not anything new that's made. Now, it can be tricky for us to tell if something new was made at all. So sometimes we like to think there's 5 different signs of a chemical reaction. Megan, do you know any of the signs of a chemical reaction?
Oh, that's a good question, Melissa. Of a chemical reaction?
Yeah.
So you would have maybe some heat escaping?
Yes. So heat, that's one sign. So that one's kind of hard, tricky for me to demonstrate. You're gonna have to take my word for it whether something is hot or not. So I didn't pick something to show that. I'm changing my safety glasses right now. They're getting a little bit foggy because masks and things. But so I have a few things here that are gonna show us some different signs of a chemical reaction. So heat, that's one of them. The next one is light. So we can, if our chemical reaction produces light, that's a sign that we made something new. Now we have another, well, I'll just show that one right now. I'm gonna get talking too much before I show something fun, so let's just do something fun. I'm going to sneak by Megan, I'm gonna turn off the lights, because this is a, well, I don't wanna give it away too much, but it's an example. I'm gonna sneak here, and I'm going to, whoops, turn out the lights quickly so we can see this reaction. Make sure not to trip on my microphone. So I have 2 liquids here. When you kind of saw them on the table before I turned out the lights. Now I can see you can't see me, so hopefully you can still hear me, and I'm going to pour one little flask into the other. That's called chemiluminescence. So that is a chemical reaction. We produced light. Now, when I turn the lights back on, you're going to see why we needed to turn the lights out to see this experiment. It's very hard to see once the lights are on. So if I go off, so we produce light. That's a sign of a chemical reaction. Now, there's another one that's like kind of hard to explain. It's easier to show, and that is the formation of a precipitate. So it's not a word, well, you hear precipitation, right? Like rain and snow. When we talk about this in a chemical reaction, we're mixing 2 liquids together, and everything in them is dissolved. And when we mix them together, something changed. So we're going to have to let it kind of settle. I'll show the next thing, and then we'll go back and look at this one. When we mix those 2 together, we have a solid that forms on the inside, and you'll see the solid gets to settle. Okay, so we talked about heat, we talked about light, we talked about precipitate. We're going to talk about gases. So bubbles and foaming can be a sign of a chemical reaction. Formation of a gas. So this is a good old vinegar and baking soda. When I did the Coke and Mentos sort of live demonstration last time, a lot of people wanted me to do baking soda and vinegar. So I got it right here this time. So let's watch the formation of a gas. So the baking soda, the vinegar, and all that bubbling, all that foam, that's called carbon dioxide. We formed a new thing. Now, sometimes something can happen, though, and we don't form a new thing. We call that a physical reaction. So something happened, but it wasn't like a new thing. So I see that Megan's going to take just a little second and see if we have any good science questions that we can answer so far.
Melissa, we do have one question, and it is, does the light ever stop glowing?
Ooh.
I think that's for the Chemiluminescence experiment.
It does, it does. It will eventually get used up. So those two products are mixing together, they're forming something new, and they are emitting light. But after a little while, it's gonna stop glowing. So I can leave it aside, and hopefully I'll remember. I can come back, we'll turn off the lights at the end and see that the light will have used up. But that's a great question. It won't keep producing light forever. I want to let this one settle just a little bit more before we look at it again. So I want to try out a few other things that can help us kind of see sort of chemical and physical reactions so that we can compare them to our Coke and Mentos fountain at the end. So I have some things here. This is some water. This is some oil. These are little Alka-Seltzer tabs, okay? And this is called Eno, so it's like a powder. And so I got different things. Now, one thing that is very important to mention, can be dangerous to mix things together if you don't know what they do. So I am trained, I have sort of designed these experiments to show you certain things. I know a little bit what's going to happen before it happens. So I wouldn't suggest people to just go and start mixing things together that they don't know what they're going to do, because that can be very dangerous. So just got to stay safe, right? So I got some water. And what I want to show here, so water doesn't have a gas in it, right? It's not bubbly, it's not fizzy. I'm going to put the Alka-Seltzer tab in, and I want to ask you what sign of if there's a sign of a chemical reaction and what that sign will be. Okay, so I'm just going to plop. Are we making something new? Maybe yes, maybe no. So we started off with water and the Alka-Seltzer, and now we have bubbles. So that is certainly, did anyone guess? That was the formation of a gas. So I'm going to let Megan take a second to look at our questions and see if anyone's got any questions so far.
No questions, but there was a question about if we were going to make a volcano.
Well, I kind of made the vinegar and baking soda overflow a little. So I want to show another something here. So this was, I had some oil, remember, in the cylinder? And I just added water, right? So this is just water from the tap. Now, something interesting, when I dropped the Alka-Seltzer tab in, you noticed it's heavy, so it goes all the way down to the bottom. And I hope that something kind of interesting might happen. So you can see the bubbles are kind of coming up and forming in the water. and then going through the oil. Just fun to watch. So again, this is kind of the same reaction. The oil just makes it look a little bit different. So the Alka-Seltzer reacted with the water, and we made something new because we see the gas.
It almost looks like a lava lamp.
Yeah, no, that's kind of, this is like an experiment that we do, that we call it like a homemade lava lamp. So we'll just like let that bubble and do its thing because it's cool. So you'll notice that that Alka-Seltzer tab is hanging out at the bottom of the cylinder, and it just keeps making more gas. Okay, so it keeps mixing more and more with the water and bubbling up. Now, I want to sort of show a contrast, something a little bit different with this Eno powder. Okay, so first, let me put Eno in here so we see what happens. Can we tell if it's a chemical reaction or not? Let's see. Fizzy, bubbly, fizzy, 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 bubbly. That means we have a gas. That means we got a chemical reaction.
Are any of these experiments creating heat, Melissa?
Ooh. Not to touch, not to touch. So maybe like if we took a thermometer before and after. And another thing, well, we'd have to turn off the lights, but I can tell you for sure, I just don't want to like sneak around and like trip on my microphone for now. But they are not producing light either. So we got like a bit of a color change here. So I want to put the Eno in the graduated cylinder so we can kind of see what happens there. Ooh, there we go, kind of like a volcano. So notice what the powder came to the top, and then it sort of fizzed and came off the top, and now it's kind of sinking to the bottom. So these act a little bit differently because of what they weigh. So the powder has a harder time sinking down to the bottom than the tab. The tab goes all the way down to the bottom. So when we have water that doesn't have a gas, and then we put something in it, and it creates a gas, then we know that we had a chemical reaction. So while I switch over, I'm going to switch over to another couple of things. I'll ask Megan to check out in our comments, if there's any questions.
There is a question, and I think you kind of answered it already, but why does the Alka-Seltzer fall to the bottom and not float on top? Is it because it's just heavy?
Yeah, so it's just heavier than water, so it falls down to the bottom, and then once the bubbles start to form off of it, then the bubbles go upwards, right? Because they're lighter than the water. So that's kind of why it falls down to the bottom. So in our description today, I said if you wanted to follow along at home, there's something that you can try. And I said you can get some materials ready. So if you have those materials, I said you needed a glass, and it doesn't need to be a glass. It just needs to be something that you can see through so you can make an observation. So I'm going to use these beakers here. Now you only need one. I'm going to try 3 different ones. But if you're trying one at home, you only need one. Now I said you're going to need a carbonated beverage. So that means like a drink that has fizz in it. So something that's different than this sparkling water is that it's got bubbles. So you'll notice when I take the cap off, it's going to have bubbles. And normal water that we get out of the tap that we drink, we can also drink sparkling water, but this doesn't have fizz to start with. So it doesn't have any gas. This already has a gas. So let's see what happens. So I said you needed some kind of fizzy beverage. It could be fizzy pop or fizzy juice or fizzy water, and raisins. So I got 3 different kinds of raisins here so that we could kind of do a little bit of a comparison, because sometimes when we see something different happen, it can help us to understand a little bit more what's happening. So I'm going to just put these here so that Megan can take a close look and show you what the different raisins are. So these are like golden raisins. I forget, I think these are Thompson raisins, they're darker raisins, and these are craisins. Okay, so they're cranberry raisins. What I want us to kind of notice is they have different textures. So the outside of them are all a tiny bit different, but they got like wrinkles, okay? Wrinkly raisins, wrinkly raisins. So if you're doing this along at home, we're gonna pour some liquid. We're just gonna pour the fizzy drink. I'm gonna open it slowly so it doesn't like explode. Okay, perfect. So now I'm just gonna pour some of the sparkling water into each of my glasses. If you only have one, that's great. So you're gonna pour the liquid in. I'm gonna go to like about halfway. If I need to add more, I'll add more. And then I'm gonna grab just a few raisins and I'm gonna put them in and then we'll watch to see what happens. Okay, so I've got maybe like 6, 7, 8 raisins here. I said in our instructions it would be like a tablespoon. So put a few raisins and a few here and a few here. Okay, so the golden raisins, they didn't do what I wanted. But can you see the Thompson raisins, Megan? Those are the darker ones in the middle. They're like going, this one is a cool one here. It's going down and then up and then down and then up. And the craisins are doing it a little bit too. I wanna like, let's put a few more. Oops. So my question for anyone who did get a chance to try this, what are your raisins doing? Do you have a sinky floaty action happening? That's what I was hoping for, sinky floaty. The golden ones, I thought they would work, but they might be heavier. So different kinds of raisins are obviously they're gonna be made differently. Maybe these ones have more sugar. I wanna like stir them a little and see if I can get, well, it's working like a tiny bit here.
Melissa, someone says my craisins are dancing.
Right? Dancing raisins, dancing craisins. Isn't that so cool? Okay, so what we learned before about chemical reactions. Okay, was this a chemical reaction? Did we form anything new? Something's happening. The raisins are dancing. So let's think about those signs again. So we had heat. Is it producing heat? Well, again, you can't see. You got to take my word for it. But it's not any hotter or any colder. So a change to make cold also counts for a chemical reaction. So light, again, we don't see any light, but we have to like turn off the lights to check. So I can do that quickly. It's important enough that I'm gonna I'll sneak by again, Megan, turn off the lights so we can confirm. No lights from the dancing raisins, okay.
Also, that would have been really, really cool.
Oh, that would have been amazing. Then we would have had a chemical reaction for sure. I got to check my list. Precipitate. Okay, we didn't form one of those. And we'll take a look. I didn't forget. We still have that one aside there. And we have color. We didn't change color. And I think I might have forgot to mention color change earlier when we talked about the signs. So a change in color and like a big change in color. You know, if you have like juice and you add a bit of water, it gets lighter. The color changed, but that wasn't really a chemical reaction. So like a drastic color change, which we didn't have. And a gas. Did we form a gas? Did we form a new gas? Well, we didn't, because the gas was already in our container. So the gas came with the sparkling water. Now, would the raisins dance in normal water? Let's just see about that. I forgot we should have compared that. So I'll take these ones because we got some sinkers. We don't really have any floating.
Some of them are
Did the golden raisins finally decide that they were gonna dance?
The middle one moved.
Maybe they're just a bit shy. They don't like to dance in front of people, maybe. Okay, so let's...
Oh, it just went to the top.
Oh, there we go. So what's going on here that's different in between like the raisins in water and the raisins in sparkling water, in fizzy water? So you see the bubbles that are attaching to the sides of the raisins. So the raisins have the wrinkles, right? The raisins have like little kind of holes the bubbles can attach onto. And see the bubbles attach together and they get bigger and bigger. When the bubble gets big enough, because bubbles want to go to the top, when the bubble gets big enough to bring the raisin upwards, it floats it up. And then it releases some of the bubbles. And then the raisin kind of gets heavy again and it goes back down. And then it collects more bubbles and then it comes up and then it lets them go and then it goes down and then it just keeps doing this until our fizz is going to be gone. Okay, so that the raisins sink to the bottom, that's really cool. And then that the gas can make them go up. That's also really cool, but not a chemical reaction, physical reaction.
Melissa?
Yes.
Someone is asking, does the sparkling water taste, what does the sparkling water taste like now? Is it raisiny?
Ooh, well, if you are doing this at home, then probably all of your ingredients are food safe. Now, because I'm doing this in the Discovery Theater, I do lots of other experiments here. Whoops, our camera just did that funny flippy thing that it does sometimes. So we'll give it a second to maybe decide to turn back the right way. So what was I lost my train of thought there. Do you remember what we were talking about?
You're in the Discovery Theater and there's...
I can't eat anything. Thank you. Everything is gross. That's where I was getting to. There's other chemicals. There's other stuff. So once things come in here, they're not food anymore. So I'm not going to taste mine. But if you're at home, you might be able to tell. Tell us in the comments if your sparkling water tastes like raisins now. So I'm just going to put this aside. Because now I want to look at Mentos. What happens when we put Mentos in water? And what happens when we put the Mentos in the sparkling water? Oh, I forgot. I need...
Melissa?
Yes.
Someone also said not to drink your science experiments in the lab.
That is exactly. It's very, very important. It's one of the first things you learn. Never eat, never drink in the lab.
Also, someone said it does taste like raisin juice.
Is that good?
I
don't know. Huh. Cool. Raisin juice. So now what I have here are some Mentos. And you can kind of come and check them out close, Megan. So one of the things about the Mentos, and I talked about this last time, their surface looks very smooth. But when you put it in your mouth, it feels very smooth. But when you look at Mentos with a microscope, they're like raisin surface, but tinier. So it has a bunch of like pits and valleys where bubbles can collect on. Okay, so remember the raisins had to collect a bit of the gas before they floated upwards. Okay, so I want to look at a difference between normal water, so no bubble water, and sparkling water, so fizzy. Sometimes when you go places and you ask for water and they ask gaz, you want gas or you want no gas. So we can have water with gas and water with no gas. So let's try here. I'm going to just put one Mentos in each so that we can see what's happening. So, nothing really happened in the Mentos and water, right? We didn't have any light, heat, precipitate, color, gas, nothing. So we didn't even really get a reaction here. What kind of reaction did we get? We got bubbling, right? We got fizz. It looks a little bit like the Alka-Seltzer, right? A little bit like the Eno when we plopped it in. More gas. Like, look, it's like a little stream of bubbles. That perfect little stream of bubbles. But is that a new gas? Nope, it's not new because it was already there. So this Mentos in Coke or pop or whatever is a physical reaction. We never made anything new. We just released the gas very quickly that was already there. So that's kind of cool. Now, the Mentos is doing what the raisins are doing, but the Mentos is too heavy to dance. So instead of the bubbles lifting up, remember the bubbles lifted up the raisins and then they went back down, the Mentos is always going to stay at the bottom. And you can see it's still producing. It's not producing gas. My mistake in speaking. It's not making a new gas. It's just releasing the gas that's already there. So I'm going to set up a couple of other things. And maybe while I'm doing that, if Megan can check out if there's questions. So I thought I would show one of the coolest things that I figured out. Oh wait, I'm not. One of the coolest things that I figured out about this Coke and Mentos experiment the last time I did it was that it reacts very differently when the temperature of the pop or of the sparkling water, actually I'm using pop, is different. So I again prepared some different temperature pops, I guess. Now the first one I want to show is the cold one, because it happens the slowest. It happens very, very slowly. So it'll let us see a little bit more easily what's happening with the Mentos. So I want to take us back to this a little bit. This is the Precipitate. Remember, we mixed two liquids together, and now there's like a solid. There's like almost like a little sludge that's at the corner here. You can see it's starting to fall and separate. So two liquids make a solid. That's a sign of a chemical reaction. You don't see it very often, but it is easier to explain if I show it, right? Okay, so let's... Now, one thing I know, since it's cold, it's not going to go up very high. So I'm going to do it on the table. So maybe the next ones I might do on the ground. We'll see. So we see as soon as I release the pressure, you see the bubbles kind of wanting to release. Now, one thing about this, and we talked about this last time, if I pour this out into a glass, then I won't get an eruption, okay? Part of this physical reaction here is the shape of the bottle. The bubbles want to rush out really, really quickly. So remember we saw the bubbles trying to rush out in the beaker, but since the beaker has a wide mouth, it didn't like that, right? So the shape of the bottle is very important, and the amount of fizz that's already in there. If you start pouring it out, you lose a lot of fizz. So your best kind of reaction with these ones is in the bottle, freshly opened. Okay, so armed with all this knowledge, and I think I probably mentioned it already, are we going to do the chemical reaction or a physical reaction? Let's watch. Not too bad, not too bad. Uh-oh, we had that camera do that thing again. Oh, close, close. There's the ceiling. Hi. Yes, because we're attached by a microphone there.
I backed up too far.
We got it?
Got it.
Whew. Whew. Okay, so so we have the same kind of thing happening there. Still bubbles are forming, but now we pushed out a lot of the gas that was there and a lot of the liquid that was already there. But we didn't make a new gas. That gas was already there. We saw it. Okay, so it's just releasing quickly. Okay, so I'll put this one aside. And we'll see, I'll do like a normal room temperature rock, or I want to say geyser. I guess geyser is a good volcano kind of. So I'll go here. So is this one going to go a little bit higher? Yeah, so a cool thing, usually reactions happen quicker when they're hotter, right? So that's something we call particle theory. If particles have more heat, they have more energy. So I'm going to do the same kind of thing, just open that up, put on. So part of why it goes so high, again, is because of the shape of the bottle and also because of this little tube that's attached there. It forces the gas to speed up as it comes out of that tiny hole. All right, let's see here. 3, 2, 1. Actually, like not that much different. I think, well, this one went probably as high as the other one, but it's on the ground, so a little bit higher. Now, another thing that I got asked a lot the last time we did these fountains was to do vinegar and baking soda with the leftover Coke and Mentos. So I like to encourage scientific curiosity within the limits of safety. So this should probably be pretty safe. So I'll take this one that's already there. I put aside some vinegar that I'll pour in the vinegar first. I'll fill it up with more vinegar and then I'll add the baking soda. Now, vinegar and baking soda is a chemical reaction and we still have our physical reaction that's kind of going on a little bit. I forgot, I didn't get 2 quantities of baking soda, I guess. I forgot. So first, and I'll probably get a funnel so that it's easier to put in. So an interesting curiosity, what happens if we mix like a chemical reaction with a physical reaction? Now the tricky part, I think, is going to be to get the baking soda into the bottle. I'll do my best and we'll see. We'll just see what happens. I'm going to take like I had the last time. Here we go. Ooh. My little, like I have like this little cup, muffin cup there that I'm going to fill up. And we'll see what happens if we mix 2 kinds of reactions. Any predictions, anyone? Does anyone? I don't even know what to predict here, so let's see. I think it's going to overflow. That's one prediction. So, yeah, we got sort of the same vinegar and baking soda. I see a lot of the baking soda got pushed out. The Mentos are still doing their thing at the bottom. It's almost like they weren't really affected by what happened on top. Let me do this. I just shook it a little. I don't know. This is all for science. I don't even know what to predict here. Nothing. Nada. Okay, well, that's cool. We still explored that curiosity. Something interesting is, even if our exploration, we didn't nothing cool happened. I mean, we still learned something. We still got to see something interesting. So the last thing I wanted to do was the warm pop, because I discovered last time that it was like very, very cool. I made a little bit of a, like a tiny bit of a mistake. I warmed them up, and I warmed them up like a little bit, maybe too warm. We're gonna see what's gonna happen. I had to put them in the freezer afterwards, so.
Melissa?
Yes.
There's a question here about Coke and using Coke.
Yes.
Does it work better with Coke?
Well, yes and no. I'll get my bottles and then I'll come back to chat. Okay, so yeah, Coke kind of has, the fizz in Coke is a little bit different. If you drank a Coke, you know that like it like feels different in your mouth. So one of the things that I only use in the Discovery Theater, and even when I did it outside at home, is only diet pop, because when there's sugar in the pop, it makes everything really sticky. So it's less about the physical reaction and more about cleaning it up afterwards. So I do have a dark pop here, so we can actually do a comparison. So I can compare the dark pop and the light pop. They're both still pretty warm, and we'll see. So it's less about the color of the pop and more about the kind of fizz. But a lot of people say that Diet Coke works the best. I wanted to use clear pop so that we could see those Mentos bubbles. Okay, it lets us to see the bubbles in the bottom. Okay.
One more question.
Sure.
What would happen if you put more than one Mentos in the bottle? Would the explosion go higher?
Okay. Well, I actually am. I'm putting 5 Mentos at a time. So in these tubes here, there's 5 Mentos. To a certain point. If I put less in, I'll have a bit less of a reaction. But if I put more in, then like it's sort of, we call it the law of diminishing returns. At a certain point, it's not gonna make more of a reaction because there's only so many bubbles that are in the pop, right? So, all right. Now this is the warm one and it's the dark one. So let's see what kind of reaction we get here. I'm a little nervous for this part. Oh, that's why I'm wearing my safety glasses anyways. I'm gonna let it gas off a little. And something that actually kind of happened with the other pop, the 7-Up, I could smell the 7-Up. So like I knew that maybe it was gassing off a little bit. And we'll see what happens with that one after we see this one. So this little device here is it loads up the Mentos, and what it does is it lets me drop them in really fast. And then they go down to the bottom. I see Megan's backing up. That's a good idea. It's a great idea. Okay. Am I under the lights or the speakers? I am not. That's how I think it's going to go. All right. Are we ready? 3, 2, 1. Woo. Cool. So one thing that we can also look at and sort of compare is how much pop or how much liquid did we push out with the gas. So this was the cold one. And the warm one, well, we won't look at it because we added vinegar, right? So they actually pushed out about the same amount of liquid. That's pretty interesting. I got Pepsi in my shoes. Who's got Pepsi in their shoes? Okay. It's going to be the last one. And I have a favorite geyser tube. I have a favorite little tube. That's weird, isn't it? It's different than all the other ones. And it's a little bit shorter. It has a little bit of a different like trigger mechanism. I don't pull the string out. I just open it with my fingers and then the Mentos fall. But what my favorite thing is that there's 3 holes at the top. So like, I don't know, it squirts cooler than just the single ones. So it's my favorite geyser tube with the hot pop. And we're going to see how this, remember, physical reaction. We went through all the motions to figure out that it's a physical reaction. And so like I said before, I could smell this when I was heating it up. So it might have lost a bit of gas. So I hope I didn't like ruin my finale. It's still hissing a little, which makes me kind of think I might be losing a bit of gas, but well, that's what we got. Okay, are we ready? Okay, let's do this. 3, 2, 1. Whoa, whew, whew. We almost got you, Megan. Are you okay?
I'm good.
You're good. Whew, that was a close one. Well, there we have it. Again, there's our little Mentos just kind of doing their thing, pushing, releasing the gas that was already there. So it can be hard for us to tell if we have a chemical or a physical reaction. So if we're not sure, then we can always go back to those and look for those 5 signs. Whether we see light. Oh, and actually I said if I remembered, I would show the light experiment that we did earlier. So it's in a little puddle of pop there. So I got Megan zooming in on it and I'll just get the lights again. So we can see that it stopped producing light. So that was a great question. I enjoyed your great science questions. So that is the last thing that I have. Well, I was just kind of recapping. If we don't know if it's a chemical reaction or a physical reaction, look for the signs. Light, heat, gas, precipitate, color change. So those are the things we want to look for. And it's important to know what our conditions are at the beginning. If we had a gas at the beginning and we have a gas at the end, then maybe we didn't form a new gas. So I'm really glad that everyone is there. I see Megan just kind of checking out comments and things. If there's any good questions, I would still love to do my best to answer them.
There is one person here who really likes your Pepsi in the shoe song.
Oh, that's good. I liked it too. I think I need a new shoe. That's.
And it seems like everyone really loved that last experiment, Melissa.
That's great. I'm glad. So thank you, everyone for being there. Thank you for being interested. Keep your eyes open, make observations, ask questions, and always kind of wonder what is going on in the world and learning together. So thanks again, everyone. Take care and happy Friday.